Hi, everyone. Hope you're not too tired and have a room for a few more talks today. My today's talk will be about integrating PostgreSQL search into Elixir's Ecto queries. And let me first introduce myself. So my name is Dima. I work as a software engineer at Software Mention, based in Krakow, Poland. I've spent almost 4 years working in Elixir, and I've started my career with machine learning in Python. Then I've joined Software Mention and worked on Membrane, which is a multimedia framework written entirely in Elixir. And now, as a part of my work at Software Mention, I'm contracting for a large United States-based company. The search. I would say that most of the apps at some point in time would need search, and it's really hard to make your search fast, relevant, and at the same time simple. And I've been working through different projects where I needed to implement search, and I've always done it differently, and there was no single place where I could read how to properly do that. So in this talk, I'll try to break down the options that you might have if you want to implement search in PostgreSQL using Ecto and Elixir. In the end of my talk, I'll suggest you a library that I wrote that will allow you to explore different strategies different strategies of search with a single line of code added to your existing Ecto query. But first, let me start with Ecto. So what is Ecto? Ecto is a database wrapper and integrated query language in Elixir. It is composable and extensible by design. So Ecto stands in between your Elixir and database. It takes a SQL, it kind of converts it to the database. So you have a SQL, and then in Ecto, you would have a schema and kind of SQL-based operators. You can combine them in any order, and then Ecto, for you, will generate a struct, convert it to a SQL, send it to the database, retrieve the results from the database, and dispatch them to you. So yeah, this is basically how Ecto works. And there are two ways that you could write queries in Ecto. The first one is using pipes, which I kind of prefer better because you can combine these pipes and you can really use the composability of Ecto. And the second way of writing queries in Ecto is using keyword lists. And by doing that, it's kind of same as pipes, but you would need to kind of pass the query to the repo in the end. And then the repo will pull a connection from the pool and send the request to the database. Why I really do love Ecto is because of its composability. In this example, you can see that we have a schema, our post, and then we can abstract away the logic that we're not interested about right now. For example, filter the posts to only published posts. You can also abstract away some authentication or authorization for your posts and have a module for that and say that return only visible to the current user post, right? And only then you can apply the search logic or any other logic that you would think of in the end. Like in this example, we just match the term. So what are the search types that I'm going to talk about today? And there are a few of them. I'll talk about pattern matching, and I'll break down in more details after this slide. I'll talk about similarity search. I'll talk about full text search. I'll talk about semantic search. And I won't talk about hybrid search, but hybrid search is kind of a mix of the 4 searches before. And I also won't talk about third-party engines and providers, since it's not a matter of this talk. So, starting with pattern matching. Pattern matching searches for a specific pattern in a string. And you could use different operators there, for example, like, I like, or similar to. And we use pattern matching when semantics of the data you search through live in data's characters. For example, we would use pattern matching search to search for phone number, or email, file name, or invoice number. So basically, the semantics of the data would live in the characters of the data. You won't tolerate typos because, yeah, the semantics are in the characters. And in Ecto and SQL, writing pattern matching search is relatively easy because it's just one clause, right? So SQL, you would write similar to. In Ecto, there is no native support for similar to operator. And because of that, you would need to write a fragment. But the fragments are kind of raw SQL strings that are passed unchanged directly to the database with these values inserted. And if you have, you might probably have multiple phone numbers, and you would need to write something like that. So it would say that the first phone number matches the pattern, or the second phone number matches the pattern. And in Ecto, the example below, you would need to write 2 fragments. So here is where the library that I wrote comes in handy. You could replace these 2 OR calls and these 2 fragments with a single call to Torus, a library that I wrote. So you could say Torus similar to, pass columns you want to search the data in, and pass the term. So it is equivalent to the example before, but just a single line of code, right? But that's not all, because you will be able, like later you'll see how Torus would simplify every search type that you have with a single line of code. So it will be amazing. Similarity search. So similarity search searches for records that closely match the input text. Basically, it will tolerate typos for you. And you have 3 options of similarity search in PostgreSQL. The first one, which will compare the whole strings. First, it generates trigrams. Trigrams are a set of characters, 1, 2, or 3, sequentially ordered. And then it compares how many of these characters do match. And the more characters match, the higher the score is. So for the first function, similarity, it just compares the whole scores of the whole words, whole strings. The second function compares word similarity, compares the subsequent matches of subsets of trigrams. So it tolerates longer strings, basically. And strict word similarity is kind of the same as word similarity, but it prioritizes full matches. So we use similarity search for fuzzy matching and catching typos in short text fields. And in Torus and Ecto, I won't provide a SQL example just because SQL becomes too complicated for now, because we need to filter and order at the same time. So there are a lot of things that we need to take care of. So I'm just speaking about Ecto and Torus. You would just say Torus similarity. You pass column or columns that you want to search in. You pass the term, and you pass optional options that I've kind of defaulted for you and picked the best ones that I think are most suitable for most cases. And in this example, we're looking for Hogwarts spelled with typos. And it correctly found Hogwarts secrets and Hogwarts secret from the post that we've previously inserted. Also, there is an option to pre-filter the results, which means that it will be much faster. You can add some GIN indexes, you can leverage them. And instead of doing a sequential scan, it will scan in the index and compare the index with the value that you have provided, and it will be much faster, but it won't return whole list of results ordered. Coming to full text search. Full text search finds strings that contain these particular terms. It does not tolerate typos, so unlike similarity search, it won't correct your typos. And it's really important as we go forward. And it supports prefix search. You can start typing a thing, and it can finish it for you. But let's dive into an example how full text search works. So in full text search, imagine we have a sentence. The cats are running quickly. First thing it will do, it'll remove stop words. So you will have only cats running quickly. The next thing it will do, it will stem every single word to its lexeme, to the base form. So you'll have cat, run, quick. The next step is it will vectorize this term based on the position in the sentence. So you'll have cat, run, quick, first, second, third. Then you'll do that to your term. You'll do that to every single row in your database, to every single document that you want to search in. And you'll compare the vectors. So that if the distance is close to each other, this means that these words probably match. right? And we use full text search when you don't care about spelling, the documents are long, or if you need to order the results by rank. So full text search is really cool if you want to search something in a large amount of data. For example, in a book, or multiple books, or multiple posts, because comparing vectors is super fast, and stemming, like creating this vector, is also relatively fast. But you probably want to store these vectors in your database. And in regards to Torus, you can also do that in a single line of code. You could say, Torus, full text, provide columns you want to search in. In this example, you'll provide post title and post body. You provide a term, and by default, Torus prefix searches the vectors. In this example, we're looking for uncovered Hogwarts. And we see that the second post we've inserted has in its body secrets uncovered in the heart of Hogwarts. And we're actually looking for that. And you see that words do not appear in the order, so they are spread across the sentence, and we still are able to find the post we are looking for. So we do not tolerate typos, but we are really cool in long texts. And the funniest and the most interesting search is semantic search. So semantic search actually understands the meaning behind words to deliver the results that match your intent. It can handle synonyms, it can handle close words, and to understand how semantic search works, we need to introduce a concept of embedding. So an embedding is a vector representing the meaning of the word text in a large, highly dimensional space. So you can imagine that this vector might have like thousands of dimensions, and if we compare these two vectors, if they are close, if the distance between these two vectors is close to each other, this probably means that they mean the same or close things. And it's really cool because you actually, if you want to search for a product, for example, and you describe what this product means, then you most likely won't use the same words as in product's description, right? And you would want to match the intent behind the search, or probably return similar products, right? So you want to probably sell something, and then you want to display that. So basically, to implement semantic search, you would need to embed your terms. You need to create the embedding from the term and embed every single document that you have stored in your database. And you would probably want to do that before. So once you insert, for example, a new post, then you create an embedding for that, either synchronously or asynchronously, using open, for example. And then you compare these two vectors together, and if they match, you return the result. We use semantic search when you need to understand the intent and handle synonyms. And as you might guess, the Torus has actually not a single line of code, but two, sorry. And in this case, you would first of all, you would generate the embeddings for the things that you have stored in your database. Using Torus to vector function, you just pass a string, and this string can be not exactly post title. You can provide post title plus post body, and many, many more things, or you can add context to that. So you generate embeddings for everything that you've stored in your database that you want to search through. Then you generate the embedding for your term, like in this example, Torus to vector a magic school in the UK. And you have this embedding vector, and then you create your amazingly complex or not query. In this particular example, it will be post, and maybe some authorization, maybe something else. Then you go ahead and write Torus semantic, pass this embedding that is stored in your database as a column, as a vector column. And then you pass the term embedding, it compares it, orders the results by ascending order, because the closer the vectors are to each other, the less the distance is. And it returns the results. And in this example, a magic school in the UK happens to be Hogwarts, and Hogwarts happens to have title Diagon Bombshell. So it returned Diagon Bombshell. And the core of semantic search is generating embeddings. And Torus has your back in generating embeddings. So Torus supports multiple embedding generators. And in these multiple embeddings generators, there are Hugging Face. How it works. So Hugging Face has an API that you send them the string, the term, and they return you an embedding. And this works in batch. You can send them a batch of terms, like a list of terms, and they'll return you a list of embeddings. Also, OpenAI works the same. Gemini works the same. PostgreSQL. PostgreSQL actually works a little differently because PostgreSQL is a Postgres extension that is shipped with Postgres binary. So PostgreSQL are Python libraries attached to Python machine learning libraries attached to Postgres binary. And because of that, you can, in SQL, invoke something like PostgreSQL embed, pass the embedding, and inside your database, generate embeddings using the model of your choice, the embedding model of your choice. Also, there is a support for local numerical Elixir serving. This means that you can host your embedding generator yourself, maybe using Flame, with an instance that has GPUs, because generating embeddings is a high computational task. And then this numerical Elixir serving will generate an embedding for you and return it. So you can own your infrastructure fully yourself. Or you can implement your own version of Torus embedding and do whatever you like. It just accepts a string, returns the vector. And moreover, you have a Torus embedding batcher. And this works, you would because of the cost of generating embeddings, you would probably want to save money, environment, and whichever you want to save. And because of that, you want to batch the requests together. So you have you only pass the requests when you have a specific amount of strings arrived or a specific amount of time elapsed, and then only then you pass that forward to any model of your choice. Also, you would probably want to cache the embeddings if you've already generated, if the embedder has seen the term, the string, then it might want to return it. So this is the pipeline I suggest you use when generating embeddings. So you have a request, then the request goes to the Nebulex cache. The Nebulex cache checks if there is a stored vector. If it's a miss, then it passes it to the batcher. The batcher waits or counts. Then it goes straight to the embedder of choice, for example, OpenAI. Then when OpenAI is done generating the vector, it goes back to the batcher. Then the batcher dispatches the request, the generated vectors back to the cache. Cache writes the cache to the cache, right? And then returns them to the client. So this is how it works. And it's, I think, kind of ideal pipeline. But yeah, you can create your own things. You own it. You could read more on semantic search and semantic search in Torus. You can just Google Torus semantic search. It'll pop up first. And optimizations. I've promised in talk description to talk about how you can optimize the search, because you want it to be relevant, that's OK. You want it to be simple, that's done. But you want it to be fast, because nobody wants to wait for things to happen, right? And for your search to be fast, I would say that every function in Torus library, Elixir library, has a documentation section on how to optimize it. So you could just, when using something like full-text search or semantic search, you could read a section on how to make it faster. Maybe you would need to add an index or pre-filter the results before applying the search. You can apply business logic, authorization, or something like that before doing any computations. Yeah, also adding indexes. And prefer faster terms. That might not be super obvious, but you have, when you select a term, for example, for I like search or some pattern matching, probably not, but I like or like search, if you do prefix search instead of suffix search, prefix searches are faster because they can leverage gen indexes. And you might want to prefer that. And again, everything is in Torus documentation. And yeah, that's it for Torus. Thank you.
Thank you, Dima. Any questions?
Hi. OK. I think, yes, first of all, it sounds really cool, very state-of-the-art in terms of search, I think, right? how much of the heavy lifting is Postgres doing in terms of the vector search? Like, or how does the vector search in embedding space happen in general?
Thanks for the question. So basically, all the comparison of vectors is done by Postgres, and it's done by a PG vector extension. So Elixir does nothing in terms of vectors and comparison vectors.